Hello class, this is a video tutorial on the intercepts and signs of functions. Before we go on into the new idea of the signs of functions, we should already know how to calculate the x and y intercepts of functions. So I'll go ahead and give you some time. You can pause the video to find the x-intercept and y-intercept for these three functions. Okay, so I hope you had enough time for that, so I'm going to reveal them. Here they are. You should have gotten 3 intercepts for this function, 2 x-intercepts for this one, and 2 x-intercepts for this one as well. If you don't quite remember how to do these, you can go ahead, go back and find this in another video, because the more important concept we'll be looking at is the signs of functions and being able to interpret them to create a snapshot of the graph. So with the x-intercepts alone and the use of a table of signs, it's possible to sketch the entire graph of the function. Granted, it's a sketch with not much detail, but we can get a snapshot of what it looks like. So here's how we do it. First, we need the x-intercepts of all the functions, or whatever function you're working with. I have them ready here. And we're going to generate a table of signs. And I'm going to demonstrate to you now how this works. The number of x values we need to pick is equal to the number of x-intercepts that we have, plus we're going to add x-intercepts that are one above and one below the values that we have. So for example, I'm going to place -2 here, and I'm going to pick one value above and one value below -2. So let's just pick -3 and -1. The next value we need is 0. Let's pick one value above and one value below. So I've already picked -1. But notice how I can't pick 1 because 1 is already one of our intercepts. So that's actually going to go here. We actually need to pick any value in between these ones. Let's just pick half because that's one value above and one value below. So when I mean a value above, it doesn't need to be exactly 1. It could be any value bigger or smaller than the x-intercept that we pick. And lastly, for one value below, let's pick half, and one value above, let's just say we'll pick 2. And now, just substituting these values back into the function, right? All we need to care about is whether it's positive or negative. You can do this in your mind, or you can use a calculator. So I'll demonstrate to you once here. Plus -3 squared minus 2 times -3. -12, I don't mind about what the value is. All I need to know is that it's negative. If we substitute -2, well, you can test it yourself, but it should definitely be 0. Oh, that's not working there. Let's just try write it again. -2 cubed plus -2 squared minus 2 times -2. Here we go. Should definitely be 0. Now, I hope you recognize that these values should be 0. So let's just finish those in now. And now let's just substitute the rest of the values in. You could type them into your calculator. I'm going to use a physical calculator now just because it's a lot faster. -1 cubed plus -2 squared minus 2 times -2. So the value here gives me 7, but all I need to worry about is that it's positive. I'm going to go through, type in 0.5. Hope you can hear that on my calculator. This gives us -0.625. All I care about is the negative. And lastly, if we put in 2, substituting 2, we get positive 8, which is positive. So this is a table of signs, because all we're worrying about is whether the graph is above or below the x-axis. So now using this, we can create a snapshot of what this might look like. So here we go. Let's draw in our x-intercepts. So let's put in -2, 0, and 1. Let's actually stretch this a little bit more. Let's make this 1. Let's make this -2. So let's scale it up a little bit. Well, we know that these are 0. Oops, sorry. So these 3 values that we put in are the zeros. And now interpreting what it says here. So it says from -2 and to the left of it, it's going to be negative. So it's going to do something like this. Between -2 and 0, it's positive. So it's going to curve up and then back down to 0. Notice how we don't know exactly where it curves up or where it curves down. All we do know is that between -2 and 0, so -2 and 0, it's positive. That's what it says here. Let's put that in. And then it says from 0 to 1, it's negative. So we know it's going to curve below and back up. And then from -1 onwards, it's positive, so it's going to curve outwards like so. There's a quick sketch of what this function may look like. So that's the general idea for all of this. You can go ahead, finish off the rest here if you'd like. I'm just going to finish off these examples, so this video might go on for much longer. Hope you get the idea. So here we go. So I've already prepared the table that we need. Let's put in the values: 0, 4, 1 value below 0, let's pick -1, a value in between 0 and 4, can be anything, let's just say 2. Let's pick a value above 4, let's just say 5. So using a calculator, actually we should already know that these are zeros. So plug in some numbers: -1 cubed minus 4 times -1 squared. We get negative. Putting in number 2, positive 2, we get negative as well. Okay, that's interesting. So it goes from negative to negative again. I'll show you what this will mean. And lastly, if we put in 5 and 5, we get positive 25. Now this is interesting because it goes from negative to negative. You'd expect it to go negative to positive, meaning it crosses the x-axis. But let's just continue and interpret what this means. Let's write in our zeros. So 0 and 4, 1, 2, 3, 4, like this. Let's sketch what this looks like. Well, it says from 0 and to the left, it's negative. Well, it's going to curve like this. But then it says also from 0 to 4, it's also negative. Well, that must mean it curves down and back up like so. If this were positive, it would mean it's crossing the x-axis at that point. But because it's negative, it's touching 0, because that's an x-intercept. But then it's reflecting back down again to become negative. And then lastly, from 4 and to the right, it's positive, so it's going to curve off to infinity like so. And let's write in those few intercepts, and there we have it. One last example. This one's a little trickier because it's an absolute value function. And just to show you that the table of signs doesn't need to be so neat, I tend to actually do it very roughly on my page. -5, let's pick a number in between, pick 0, 1, 2, pick -6. And You don't need to use a calculator, just use your head for this one. Let's just say, in our mind, negative 6 plus 2. Well, negative 6 plus 2 is negative 4. Absolute value is positive 4. Take away 3. Well, that's positive. Doing this again, we know that negative 5 we've already solved to be an X-intercept, so we know that's going to be 0. And so is this one. Well, let's try 0. 0 plus 2. Absolute value of that, take away 3. Well, that should be negative. Lastly, if we put in 2, 2 plus 2 is 4. Take away 3. That's positive. Writing in our X-intercepts. So 1 is here. 1, 2, 3, 4, 5. Let's say 5 is there. And now, normally, we would draw this as a curve, but we know that it's going to be an absolute value. So, in case you don't know, in absolute value functions, exactly halfway between both of them is going to be the vertex. So 1, 2, 3, 1, 2, 3. So this point here is exactly halfway. At that point, that's where the vertex is going to be. So let's draw a sharp point like this. And now I knew it's going to go below the curve because interpreting it again, from negative 5 and to the left, it's positive. There it is, negative 5 and to the left, the graph is going positive. Between negative 5 and 1, it's negative. So between negative 5 and 1, it's negative. And from 1 and to the right, it's positive. 1 and to the right, the graph is positive. So I hope I gave you an insight into a table of signs to interpret what a function may look like. So I hope to see you in the next video. And yeah, best of luck.